Sugarcane, sweet sugarcane, the sweetness of our southern trees.
All right, good morning, everyone. Thank you, Paul, for the introduction. So for the next 15 minutes, I'm going to try to ignore what's going on outside, all the wet weather. We're going to try to dry things out and heat it up a little bit in here. So the majority of sugarcane acreage is green cane harvested. And if you look at the amount of post-harvest residue that comes out of that machine, depending on the variety, the year, and the crop, it can vary between 2 to 10 tons per acre of post-harvest residue. And it's well known that if we don't remove that residue in a timely fashion before the spring green up, we can see about a 13% reduction in sugar yield. So after we harvest the cane, we're really left with two options with that trash residue blanket. We can either rake it, and that's very common in areas around schools or hospitals where burning is kind of frowned upon and much more difficult to do. But on the left, burning it, this is a very common approach in the industry. And if you look in the literature, many weed seeds are susceptible to heat. If you look at Japanese brome, spotted knapweed, Russian thistle, these aren't weeds that we're specifically encountering with in sugarcane production, but they're very common in prairies. And they found that about 120 degrees to 250 degrees Fahrenheit, with a prairie burn, about 20 to 2 hours, they can greatly reduce the amount of surface deposited weed seed. But if we look at itchgrass, I know many of you have this weed in your fields, very common in ditch banks and around the industry. We found that exposure to itchgrass exposed to 400 degrees Fahrenheit for as little as 20 seconds, we can see a great reduction in the seed viability. We look at some other species, specifically wild radish, which is very problematic in Australia, and annual ryegrass, which we have here in the northern part of the cane belt, quite prominent. It takes quite a bit more heat to get an acceptable level of control on those surface deposited seeds, greater than 750 degrees for about 10 seconds. So, as I previously mentioned, the amount of residue can vary quite a bit, as much as 2 to as little as 2 to as much as 10 tons per acre of post-harvest residue. But another factor that we have to think about, when we're burning, is a lot of times we get in situations where we've experienced a rainfall before we had time to burn that. And in this picture here, I've been in this situation before on our farm where are we going to try to burn this residue when it's a little bit wet? I think I can get it going. But oftentimes what ends up happening is you get a partial burn. The row top burned here, but this water in the wheel furrow didn't allow that flame to catch over to the next row. If you look on the right here, this was burned a couple days after harvesting it, and as you can see, it's pretty bare and a really good, efficient burn. So the objectives of this research trial, this was some small plot project that we did. And we wanted to look at the effect of burning post-harvest residue density, going all the way down to 2 tons per acre and up to 10, and looking at what is the effect on itchgrass and divine nightshade emergence on the soil surface. So I just want to make that clear. We're not talking about itchgrass seed buried an inch or below that, on the soil surface. And the second thing we wanted to look at was determine if the post-harvest residue was exposed to a simulated rainfall event. And does that compromise burning efficiency and increase a weed seed emergence? So just some brief materials and methods. We collected the post-harvest residue from the field here with the loader. We brought it into our climate-controlled shop. We sifted out all the large chunks of soil, and we had a predetermined area that we were going to burn all this residue on. So we actually had to put the residue in burlap sacks and weigh it before we burned it. So we had a known weight, and we extrapolated that out to 2.7, 5.4, 8.1, and 11 tons per acre. So we actually didn't collect thousands and thousands of pounds of residue. We brought it down to a smaller scale, just to kind of give you guys a picture of what we're doing. So the bags out here, these were the ones that were exposed to a simulated rainfall. So eventually what we did was we had our burlap sack. We took a garden hose and put it over top of the burlap sack and let that water kind of percolate through to simulate what would be a rainfall event. And those bags remained outdoors for 3 days before the burning experiment, before we lit it up. So for the seed preparation, yeah, we actually had to count itchgrass seed and inspect them before to make sure that we had high quality seeds that were going to germinate, so we could indeed tell that the burn treatment worked. And then for our divine nightshade, so within each berry here, there's about 50 to 100 seeds. We weighed them, and we're looking about a quarter gram. We wanted to get berries of the equivalent size, which would have a similar amount of seeds, so we would kind of reduce the variability in the seed. So for the burn day here, we had a 4-inch pot right here. We dug a hole, and we put that pot down in there to where the top of the pot was flush with the soil surface. We put a little mesh screen so we wouldn't lose any seeds or berries when we were working with it. And we put that residue over the top of this designated burn area. We had soil probes there to measure about a 1/2 inch below the soil surface, and then one right on top of the soil surface where the seeds are located. And then we burned it. We got a few looks. We left all these Coke cans and poles out there. We had some comments from the farm crew thinking that we were having a hog roast or something like that. But as you can see, at the end, this is what was left. And after we burned it, we brought those pots back to the greenhouse. And looking at this picture here, you can tell, well, here we got some itchgrass that's starting to pop up. These treatments were likely the non-treated or the really low residue amounts. But you can see some of the treatments worked pretty well. We didn't have any nightshade or any itchgrass emerging. So we wanted to determine, too, what is the amount of moisture that we had in the residue. So we did see an interaction here at the experiment. So this is run 1 and run 2. We had quite a bit more moisture within that residue in run 2, and that was attributed to cooler days and nights when that residue was sitting out. And it was also really cloudy, which didn't allow that residue to really dry as much as what we saw in run 1. And interestingly, as we increased the amount of post-harvest residue, the low residue amounts had more moisture, which makes sense because we had the same amount of water was able to saturate a very small amount of actual biomass. And then, not surprisingly, this 6% moisture of the dry condition, this was like kindling. So that stuff lit up very well whenever we burned it. So the climate conditions, environmental conditions at time of burn, this is kind of important, I think. If we look at run 1, we had an average wind speed of about 13 miles per hour. But in run 2, we only had about an average wind speed of 5 miles an hour. And I'll kind of link that up later with some of the results. So here we have, on this table, table 3, we have exposure time. So this is the amount of seconds that those seeds were exposed to 200, 300, and 400 degrees Fahrenheit. And as I just said previously, remember in run 1, we had about a 13 mile an hour wind speed. In run 2, we had 5. I think what happened here, we have less time that those seeds were exposed to the heat. And I think that was attributed to the wind currents extinguishing a lot of the wet residue. So we had an incomplete burn. And if we look at the amount of post-harvest residue, not really surprising, as we increase the amount of post-harvest residue, 2.7 tons per acre to 10.8 tons per acre, we had more time that those seeds were exposed to those temperatures, which would think that we would get better mortality, more weed seed kill. The only person this probably excites in the room is Dr. White, because I got the soil horizons right here. And so my main message here is that seed, when it's buried a ½ inch or a ¼ inch below the soil surface, look at the maximum temperature, a ½ inch below the soil surface, 88 degrees with 10 tons per acre of residue. So that just gives light to how well the soil insulates the temperature. And 88 degrees, that's kind of a mild summer day in southeast Louisiana. So not going to have much effect on the seed. But just a ¼ inch or a ½ inch on the other side, on the flip side, we saw as much as 1,000 degrees Fahrenheit with the 10.8 tons per acre rate. And this is maximum temperature. Not surprisingly, the dry residue, the temperature was much hotter than it was at the moist residue. And then in experiment 1, where it was a little bit more blustery, the air temperature at the soil surface was a little bit lower than when the wind speed was more calm. If we look at the burn duration, again, this kind of makes sense. The more residue that we had was the longer the burn was. So when we had 10 tons per acre, this is about a 10-minute burn. And the burn was determined when we lit it to when the soil surface temperature was 100 degrees or below, is when we said the burn was finished. Here, this is just some figures. So on the y-axis, we have weed emergence. So this is both nightshade and itchgrass. And on the x-axis, we have our post-harvest residue amount. So a low amount, 2.7, and it's increasing as we go from left to right. Our solid line, this is the moist residue, and the dotted line was the dry residue. So what really interests me here is that this low residue amount, when it was wet, we had quite a bit of seed emergence. So the lower the number, the better. That would mean it would be killed. The higher the number, that's not good. So the next question is, okay, well, this is total weed emergence, but is there a difference between the itchgrass and the divine nightshade? And that gives evidence right here. The solid line is divine nightshade, and the dotted line is itchgrass. So predominantly, almost 60% emergence occurred with divine nightshade versus about 35% at that low residue amount. And so just to summarize some things, burning can be effective. It's part of an integrated weed management system. It's not the whole option. It's not the whole thing. It's part of that system. And again, that's only going to help with the surface deposited seeds, not the ones that are buried below the soil surface. We did see about 56 to 90% of the itchgrass and divine nightshade seeds that were controlled with prescribed burning, considering those estimates of post-harvest residue of 2.7 to 10.8 tons per acre. Keep in mind fields that have poor stands, or especially when the post-harvest residue is abundantly wet, or when we get water that ponds in the furrows, we're not likely going to have temperatures high enough to control those seeds on the soil surface. And then for those of you who aren't really familiar with divine nightshade, it's almost like picking a little blueberry. All those seeds are encompassed in a fluid material, and that fluid, fleshy material, it really protects the seed from short periods of high temperature. But it may not protect those seeds long enough when we have more of a composting type effect, so low temperature for several minutes, 8 to 10 minutes, or like a smoldering fire. It kind of depends. So there's really two biotypes of itchgrass, and it also depends on the emergence timing. So those itchgrass that emerge in February, March, those are going to have a lot more seeds, and they tend to kind of bush out, and that's what we see with the, I call it the Ardone biotype, but it's the St. Martinville biotype, and that one is not sensitive to day length. After about 2 months, it's producing seed. But the other biotype, which is the cloverleaf biotype, when the day length begins to decrease, it begins to flower and produce seed. It's not as common as the St. Martinville biotype, but probably, I'm going to say a couple thousand, 3,000 seeds per plant. And those seeds can hang around for quite a long time, especially if they're kind of buried and protected underground.
Sugarcane, sweet sugarcane, the sweetness of our southern